Hey guys, welcome to the structure module. This video is going to be a quick introduction to why structures are important and the basic types of support for a structure. Structures are important because we want it to be stable and to hold things. Things like buildings and bridges, they have to hold tons of weight, so we want to make sure the physics behind the structure is very stable and sound. So for example, this is the Golden Gate Bridge, a type of suspension bridge, and by the end of this module, we want to be able to take this bridge, break it down to its core physical structure. So let me draw the core physical structure right here. Um, and we want to be able to look at certain points and see the forces acting on those points and see if the structure will hold with the load that we put on it. So let's go over some key definitions. So first of all, what is a structure? A structure are things that we construct that are made of beams and trusses. So oftentimes you'll see structures in the form of like a bridge, and sometimes they'll look like this. So here's an example of a structure right here. And beams are elements of that support load by bending between the trusses. So a beam would be one of these lines right here, and that would be a beam. And with a beam, we are going to be able to identify the forces on that beam to see if it will bend plastically, it will stretch elastically, kind of like what we did in the material segment. So now we're going to talk about the different types of supports. The first support is called a cantilever support or a wall support. It's going to look something like this with the wall at the end. So we're going to identify 2 points on this beam, A at the beginning, B at the end. Some characteristics. At A, it cannot move in the X or Y direction because it's fixed there, and also can't move in the theta direction. That means it can't spin like that. It can't do that. Now, some things, if I were to draw this wall, if I want to identify the forces later on, an equivalent drawing with reaction forces, there could be a reaction force in the Y direction, a reaction force in the X direction, and also a moment in the Z direction. So the next type of support is going to be the pin support, otherwise known as the pivot support or the hinge support. And it's going to look like this with a triangle down here and your beam right here. And you can imagine that it can move in the angle. So some key constraints is that if I were to label this A and B, the change in position in A in both the X and Y direction will be 0 because A is going to be fixed there, but it can move in angles. The angle is no longer fixed. As for reaction forces, I can draw the beam again right here. And there's going to be a reaction in the X direction and the Y direction, not in the angle direction like last time. So reaction A at X and reaction A at Y. And those are the key points of a pivot support. So our last type of support is going to be called a roller support. It's really indicated by this ball and a beam. So you could imagine that it's on a roller, so it could move in the X direction, and it could also move in the theta direction. It's no longer constrained there. So the only constraint is going to be that if this was A and B again, the change of position in A in the Y direction would be 0. It can move in the X and the theta direction. So let's draw the reaction forces right now. That's our beam again. And this one, there's only a reaction force in the Y direction. So it's going to be RAY. And that's it. So that's a roller support. So now we're going to go over a couple of examples, just some reminders. We're working with static equilibrium, so that means the forces in the X, Y, and the momentum will all have to be equal to 0. And here on the right, we have a couple of sign conventions. We're going to make X going to the right positive, Y going up positive, and Z coming out of the page positive. So here's the first question. So we have a support here with the force going down on it, and what we're going to try to do is find the reaction forces at places. So the first thing we can do is write the reaction forces on the beam. So we're going to redraw the beam right here. So we're going to redraw this beam with the reaction forces. So let's start off with writing this F first. That force is already there. The reaction forces, this is a pivot. So that means we know there's a reaction force in the Y direction and also in the X direction. And over here, it's a roller. So we know that there's going to be a reaction force only in the Y direction. So now we're going to write our equations of equilibrium. So we know that the force in the X direction, the forces in the Y direction, and the momentum at every point, in this case we're going to choose point A, is all going to be equal to 0. So now it's a matter of just writing our equations. So all the forces in the x direction, there's only force AX in the x direction. We're going to look at all the forces in the y direction. We know that there's a y going up, force going down, and by going up. And now momentum. So you have to remember momentum is going to be force times distance. So in this case, everything is perpendicular, so we don't have to worry about this. So the force times distance here. So force F times the distance, which is 2/3 L. And we're going to also look at the force B times the distance, which is L. So now it's just a matter of solving. So we're going to solve this first. Solving this equation, we're going to get B equals to 2/3 F. And now we can solve for this equation, and we're going to end up getting that A in the y direction is equal to F over 3. So now we solve the entire question.